managed to pickpocket my own phone back.
That's true. When you look around, you see both living and non-living things. You must have wondered and asked yourself, what is it that makes an organism living? Or what is it that an inanimate things do not have, which a living things has? The answer to this is the presence of basic unit of life, that is cell, functional unit. Okay, the cell is the cell in all living organisms. All organisms are composed of cells. Some are composed of single cells and are called unicellular organisms, while others like us composed of many cells and are called multicellular organisms. What is a cell? Unicellular organisms are capable of independent existence and perform their own function, performing the essential function of life. Anything less than a complete structure of a cell does not ensure independent living. Anything less than a complete structure of cell does not ensure independent living. Hence, cell is the fundamental and structural. Cell is fundamental and structural. Cell is fundamental and structural unit of life. Fundamental, structural, and functional unit of all living organisms. Of all living organisms. Fundamental, structural, and functional unit of all living organisms. Anton von Leeuwenhoek, first to discover living cell. Okay, first saw and described live cell. Anton von Leeuwenhoek. Anton von Leeuwenhoek first saw and described live cell. Robert Brown. Robert Brown later discovered nucleus. Robert Brown, nucleus. Okay, the invention of microscope and its improvement leading to the electron microscope reveal all the structural details of the cell. Okay, तीनजना साइन्टिस्ट को कति भन्नु त Schwann, zoologist, त्यहाँदेखि Sheldon, botanist, Schwann, Sheldon, Sheldon, and one more is there. I think is Rudolf Virchow or something like that. Sheldon and Schwann along with Rudolf Virchow, yes. Cell theory, okay. Coined by Robert Hooke, dead cell. Robert Hooke, okay. Robert Brown, nucleus. Cell theory. 1838, Matthias Schilden, a German botanist, examined a large number of plants and observed. Okay, Matthias Schilden, a German botanist, examined Schilden, a German botanist, examined a large number of plants and observed that all plants are composed of cell wall, different kinds of cells. Okay, different kinds of cells. All plants are composed of different kinds of cells, which forms the tissue of the plant. At the same time, Schwann, Theodore Schwann, a British zoologist, studied different types of animal cells and reported that cell had a thin outer layer which is today known as plasma membrane. He also concluded that based on plant tissue, that the presence of cell wall is a unique character of plant tissue, plant cells. Okay, unique character of plant cell. On the basis of this, Schwann proposed the hypothesis that the bodies of animals and plants are composed of cell and product of cells. On the basis of this, Schwann proposed the hypothesis that are On the basis of this, Schwann proposed the hypothesis that the bodies of animals and plants are composed of cells and product of cell. Bodies of plants and animals are composed of cell and cell products. Schilden and Schwann together formulated cell theory. This theory, however, did not explain as to how new cells were formed. Rudolf Virchow, 1855, first explained that cell divided and new cell are formed from pre-existing cell, omnicellula, ecellula. New cells are formed from pre-existing cell, omnicellula, ecellula. He modified the hypothesis of Schilden and Schwann. Rudolf Virchow modified hypothesis of Schilden and Schwann to give the cell theory a final shape. Okay, all living organisms are composed of cell and product of cells. All cells arises from pre-existing cells. Okay. An overview of cell. You have earlier observed cells in an onion peel and or human cheek. Cells under the microscope. Let us recollect their structure. The onion cell, which is typical plant cell, has a distinct cell wall as its outer boundary, and just within it is the cell membrane. थाहा थिएन, अहिले भर्खर ल्याइदिनु राखेर मात्रै देखेको. मलाई अस्ति डाउट लाग्दै थियो कि तर सोध्नै अप्ठ्यारो लाग्यो नि त. उनका ना एक बकेट चोरी हो गया था तो वो बोल रही क्यों नहीं मिल गया. The onion cell, which is a typical plant cell, has a distinct cell wall as its outer boundary, and just within it is the cell membrane. The cell of the human cheek have an outer membrane. The cells of the human cheeks have an outer membrane as the delimiting structure of the cell. Inside each cell is a dense membrane. Bound structure called nucleus. Inside each cell is a dense membrane bound structure. Structure called nucleus. The nucleus contains the chromosome. Which in turn contains genetic material. Nucleus contains chromosomes contain genetic material, DNA. Cells that have membrane-bound nuclei are called eukaryotic, whereas cells that lack a membrane-bound nucleus are prokaryotic. In both prokaryotic and eukaryotic cell, or semi-fluid matrix, cytoplasm, right, called cytoplasm. Semi-fluid matrix Cytoplasm occupies the volume of the cell. Cytoplasm occupies the volume of the cell, semi-fluid matrix. Okay, the cytoplasm is the main arena. Cytoplasm is main arena for cellular activities in both plant and animal cell. In both plant and animal cell, both plant and animal cell, various chemical reactions occurs. Various chemical reactions occur in it to keep the cell in the living state. Beside the nucleus, the eukaryotic cell have other membrane-bound distinct structures called organelles like endoplasmic reticulum, mitochondria, Golgi bodies, lysosome, endoplasmic reticulum, okay, ER, Golgi complex, lysosome, mitochondria, microbodies and vacuoles. Lysosome, okay, tonoblastron छैन स्कोप already. Lysosome, mitochondria, enzyme हुन्छ यसको भित्र, hydrolytic enzymes. Microbodies, microbody, lysozyme, suicidal bag. Lysosome, vacuole, microbodies, membrane bound minute vesicle called microbodies that contains various enzymes are present in both plants and animals. Peroxisomes, plant and animal cell. Peroxisomes, enzyme present. H2O2 metabolizes. Catalase and peroxidase. मैं ये करना भूल गई क्या? मुझे नींद नहीं आ रही थी इसलिए मैं वापस आ गई, लेकिन ना मैं कमेंट ऑफ करना भूल गई. अभी कर देती हूँ. Microbodies, okay, and the vacuoles. Organelles like the endoplasmic reticulum, ER, Golgi complex, lysosome, mitochondria, microbodies. Lysosome, mitochondria, microbodies, and vacuoles. The prokaryotic cell lacks such membrane-bound organelles, okay. इसको एग्जांपल ये रखियो. पेरोक्सिसोम्स है ना, इसको एग्जांपल. पेरोक्सिसोम्स, yes. माइक्रोबॉडीज को एग्जांपल हो पेरोक्सिसोम. Peroxisomes and vacuole. The prokaryotic cell lacks such membrane-bound organelles. Okay, got that. Ribosomes are non-membrane bound. They don't have any membrane. Ribosomes are non-membrane bound organelles found in all cells, both eukaryotic as well as prokaryotic. Non-membrane bound ribosomes. Within the cell, ribosomes are found not only in the cytoplasm, they are found not only in cytoplasm but also within two organelles. This is mitochondria, ER, endoplasmic reticulum. Chloroplast in plant and mitochondria, and on rough ER, rough endoplasmic reticulum, obviously. Mitochondria, even in chloroplast in plants, okay? But within two organelles, chloroplast in plants and mitochondria, and on rough ER, okay? Cytoplasm मा हुन्छ, mitochondria मा हुन्छ, ER मा हुन्छ, and chloroplast in plant. Don't forget this one. Chloroplast in plant. I know I will forget this one. I have to mark it. Non-membrane bound, okay? Ribosomes. Chloroplast in plants. Animal cell contains another non-membrane bound organelles called centrosome. Centrosome. एउटा सेन्ट्रियोल हुन्छ, अर्को के हुन्छ सेन्ट्रोसोम्स. इसको ना ऐसे कर देते हैं. Animal cell contain another non-membrane bound organelle called centrosome, which helps in cell division. Animal cell contain another non-membrane bound organelle called centrosome. दुईटा सेन्ट्रियोलले बनिन्छ सेन्ट्रोसोम. सेन्ट्रोसोम हेरमा छ सेन्ट्रोसोमको स्ट्रक्चर. Here it is. This one is centrosome. दुईटा सेन्ट्रियोलले बनिन्छ सेन्ट्रोसोम. Okay, centrosome. Another animal cell contain another non-membrane bound organelles. Non-membrane bound organelle. Okay, centrosome. Non-membrane bound organelle. Non-membrane bound organelle. Centrosome, which helps in cell division. केमा help गर्छ ले cell division मा, which helps in cell division. Helps in cell division. Cell division मा help गर्छ. Cells differ greatly in size, shape, and activities. For example, mycoplasmas, the smallest cell, are only 0.3 mycoplasma. So the cell wall पनि हुन्छ mycoplasmas. Mass पनि amount. The smallest cell are only 0.3 micrometer in length, while bacteria could be 3 to, ये तो मैं भूल जाऊंगी, bacteria 3 to 5 micrometer. Mycoplasma 0.3 micrometer, bacteria 3 to 5 micrometer. The largest isolated single cell is ostrich egg. Largest isolated single cell is the egg of an ostrich. Largest isolated single cell is the egg of an ostrich. Among multicellular organisms, human red blood cells are about RBC. Okay, RBC are about 7 micrometer in diameter. Okay, nerve cells are some of the longest cells. Cells also vary greatly in their shape. They may be disc-like. Okay, disc-like, polygonal, columnar, cuboidal. Okay, they may be disc-like, polygonal, columnar, cuboid, thread-like, or even irregular. They may be disc-like, polygonal, columnar, cuboidal, thread-like, or even irregular. The shape of the cell may vary with the function they perform. Okay, nerve cells are longest. Nerve cells are longest cells. Shape, they may be disc-like, polygonal, columnar, cuboid, thread-like, or even irregular. The shape of the cell may vary with the function they perform. RBC, red blood cell, round and bioconcave. Red blood cell, round and bioconcave. RBC, WBC, amoeboid. WBC is white blood cell, amoeboid. Okay, columnar epithelial cell. Columnar epithelial cell. Columnar epithelial cell. Columnar epithelial cell. Columnar epithelial cell, long and narrow. Long and narrow. Columnar epithelial cell, long and narrow. Okay. Mesophyll cell, round and oval. Mesophyll cell, round and oval. Mesophyll, plant mounds, leaf mounds, chloroplast mounds, obviously. Or trachid, elongated. Nerve cell, branched and long. Okay. Prokaryotic cell. The prokaryotic cell are represented by bacteria, blue-green algae, and mycoplasma, and PPLO, pleuropneumonia-like organisms. They are generally smaller and multiply more rapidly than the eukaryotic cell. They are smaller, generally smaller, and multiply more rapidly than the eukaryotic cell. Figure 8.2. They may vary greatly in shape and size. The four basic shape of bacteria are bacillus, rod-like, coccus, spherical, vibrio comma-shaped, and spirillum, spiral. It's okay, Ima. The organization of the prokaryote cell is fundamentally similar. The organization of the prokaryotic cell is fundamentally similar, even though prokaryotes exhibit a wide variety of shapes and functions. All prokaryotes have a cell wall surrounding the cell membrane. All prokaryotes have a cell wall surrounding the cell membrane. Cell wall surrounding the cell membrane. Okay, cell membrane surround the cell. Prokaryotes ma ke huncha cell wall. I think glycocalyx bhन्छ outermost. Then plasma membrane, त्यसको बाहिर पनि केही हुन्छ. I forgot. There are 3 layers, I know. Cell prokaryotes have a cell wall surrounding the cell membrane except in mycoplasma. Mycoplasma do not have cell wall. The fluid matrix filling the cell is the cytoplasm. There is no well-defined nucleus. The genetic material is basically naked, not enveloped by a nuclear membrane. In addition to the genomic DNA, the single chromosome circular DNA. In addition to genomic DNA, the single chromosome circular DNA. The genetic material is basically naked, not enveloped by a nuclear membrane. It's okay, Ima, don't think about it. The genetic material is basically naked, not enveloped by a nuclear membrane. In addition to genomic DNA, the single chromosome circular DNA, many bacteria have a small circular DNA outside the genomic DNA. Small circular DNA, plasmid bhन्छ यसलाई. Many bacteria have small circular DNA outside the genomic DNA. Outside the genomic DNA outside the genomic DNA. These smaller DNA are called plasmid. The plasmid DNA confers certain unique phenotypic character to such bacteria. One such character is the resistance to antibiotics. Such a character is resistance to antibiotics. In higher classes, you will learn that the plasmid DNA is used to monitor bacterial transformation with foreign DNA. Nuclear membrane is found in eukaryotes. No organelles like the one in eukaryotes are found in prokaryotic cell except for ribosomes. Prokaryotes have something unique in the form of inclusions. A specialized mesosomes, right? A specialized differentiated cell membrane. Differentiated cell membrane called mesosomes. Specialized, okay. Prokaryotes have something unique in the form of inclusion. A specialized differentiated form of cell membrane called mesosomes is the characteristics of prokaryotes. They are essentially infoldings of cell membrane. Mesosomes are infoldings of cell membrane. Typical bacteria 1 to 2 micrometer, PPL 0.1 micrometer, virus is 0.022 to 0.2 micrometer. ये सब में इतना ज़्यादा डेटा है ना कि मैं भूल जाऊंगी. Cell envelope and its modification. Most prokaryotic cells, particularly the bacterial cells, have a chemically complex cell envelope. The cell envelope consists of a tightly bound 3-layered structure. Outermost glycocalyx, followed by a cell wall. Cell wall, then plasma membrane. 3-layered हुन्छ. Glycocalyx, cell wall, and plasma membrane. Okay, tightly bound. The cell envelope consists 3 layers. 3 layers cell envelope को glycocalyx, cell wall, and plasma membrane. Although each layer of the envelope performs distinct function, they act together as a single protective unit. Okay, bacteria can be classified into 2 groups on the basis of the difference in the cell envelope and the manner in which they respond to the staining procedure developed by Gram-Wise. Those that take up the Gram stains are Gram-positive, and the other that do not are called Gram-negative bacteria. Gram stains. Take up Gram stain. Gram-positive. Do not take Gram stains. Gram-negative bacteria. Okay. Bacteria can be classified into 2 groups basis on the basis of the difference in the cell envelope. Gram-Wise. Okay. Glycocalyx differ in composition and thickness among different bacteria. Okay. Slime layer पनि हुन सक्छ कुन-कुनमा thick capsule पनि हुन सक्छ. Glycocalyx differ in composition and thickness. Differs in composition and thickness among different bacteria. It could be loose sheath छ भने के हुन्छ slime layer. Okay. In some, while in other it may be thick and tough. Differs in composition and thickness. Capsule, thick and tough. called the capsule. The cell wall determines the shape of the cell. Cell wall determines the shape of the cell. Cell wall determines shape of the cell and provides a strong structural support to prevent the bacterium from bursting or collapsing. Bursting or collapsing. The cell determines the shape of the cell and provides a strong structural support to prevent the bacterium from bursting or collapsing. I can't take this anymore. Determine the shape of the cell and provide a strong structural support to prevent the bacterium from bursting or collapsing. Cell wall determines the shape of the cell. The cell wall, in others, the shell wall, determines the shape of the cell and provide a strong structural support to prevent the bacteria from bursting or collapsing. Cell like collapse हुनुबाट कसले बचाउँछ? Cell wall ले बचाउँछ. Okay, shape पनि दिन्छ. Determines the shape of the cell and provides a strong structural support. The plasma membrane is selectively permeable in nature and interacts with the outside world. This membrane is similar structurally to that of eukaryote. Okay, this plasma membrane. Okay. I want to sleep. Slot 4 complete भी हो गया. A spatial membranous structure is the mesosome, which is formed by the extension of plasma membrane into the cell. The extensions are in the form of vesicle, tubules, and lamella. In the form of vesicles, tubules, and lamella. A spatial membranous structure is the mesosomes that is formed by the extension of plasma membrane